All right, good afternoon. This is Titan Learning Day 33 and 34. Totally new stuff here. This is discussing angle identities. Okay, so we're going to have some properties that we're going to use and apply to different verifications and solutions. So with our angle identities, the first property that we have will be our negative angle identities. So the sine of negative theta is negative sine theta. The cosine of negative theta is positive cosine theta. And the tangent of negative theta is going to be negative tangent theta. So these are just givens that we need to know. We also have cofunction identities. So the sine of pi over 2 minus theta equals cosine theta. The cosine of pi over 2 minus theta is sine theta, and the tangent of pi over 2 minus theta is cotangent theta. So how do we go about verifying an angle identity? All right, they want us to verify the identity sine theta minus pi over 2 is equal to negative cosine theta. So we've got to move from this to this through a series of substitutions. So sine theta minus pi over 2 would be equal to sine of negative pi over 2 minus theta. And that is the rule out here to the right. So this is my verification for it. B minus A equals negative A minus B. Then I can say negative sine pi over 2 minus theta because of my negative angle identities. Then, once I know this, I go back up to my cofunction identities, and I can see that sine of pi over 2 minus theta is actually equal to cosine of theta. So that's what we would get, and that's how we would verify it. Let's look at another example. What are all the values that satisfy sine theta equals sine of pi over 2 minus theta within the range of 0 to 2 pi? Anytime you see this, you're going to have to do some kind of work to get a second answer. Okay, that's kind of like a flag. All right, so I have sine theta equals sine pi over 2 minus theta. So I'm going to have sine theta equals cosine theta, and that's our cofunction angle identity. Now, if I divide both sides by cosine theta, I'm going to get sine theta over cosine theta equals 1. And sine theta over cosine theta is going to equal tangent. So tangent equals 1. And then to solve for theta, I'm going to say the inverse tangent of 1. So theta is going to equal pi over 4. Now, I'm looking within the range of 0 to pi over 2. So another solution is going to be pi over 4 plus pi, which will give me 5 pi over 4. So both of those would be solutions to that problem. All right, let's look at angle difference identities. And I'm going to have 3 of these. The sine of A minus B is going to be sine A cosine B minus cosine A sine B. Cosine of A minus B is cosine A cosine B plus sine A sine B. And then tangent of A minus B is going to be tangent A minus tangent B over 1 plus tangent A times tangent B. Don't worry about, oh, I don't know if I can remember these, so on and so forth. You're going to have these on your notes to look things up. So right now, just make sure you know how to work with these. And then next year, if it's a requirement that you memorize them, you can memorize them then. Right now, I want you to concentrate on knowing that unit circle to make your life easier. So what is the exact value of cosine of 15? All right, so let's go with cosine A minus B. And I'm going to say cosine A, cosine B plus sine A, sine B. So to get 15, I'm going to say 60 minus 45. Cosine 60, cosine 45 plus sine 60, sine 45. Okay, now we're just sticking, substituting, plugging in where we know it belongs. What is the cosine of 60? What is the cosine of 45? What is the sine of 60? What is the sine of 45? We fill all those in. Then we have the square root of 2 over 4 plus the square root of 6 over 4. We can't add those square roots because they're not identical, but we have a common denominator, so we can say it's the square root of 2 plus the square root of 6 over 4. All right, more properties. These are the angle sum identities. So I've got the sine of a plus b equals sine a cosine b plus cosine a sine b. I have cosine a plus b equals cosine a cosine b minus sine a sine b. And I have tangent a plus b is going to be tangent a plus tangent b over 1 minus tangent a tangent b. When you compare them, okay, you see that they're the same, except for on this one I'm subtracting, this one I'm adding, this one I'm adding, this one I'm subtracting. And on this one I subtracted, so I had to add, and I added, so I had to subtract. So those are the differences if you're trying to memorize these. Let's look at how this applies. What is the exact value of sine of 105 degrees? There we go. So I'm going to use sine, and I'm going to use sine a plus b. So here is what the sine of a plus b is. To get 105, the ones that we know really easily are 60 and 45. So I'm going to add those together. I'm going to substitute where necessary, and then I'm going to get the actual values. So when I multiply the square root of 3 times the square root of 2, that's the square root of 6. 2 times 2 is 4. 1 times the square root of 2, square root of 2. 2 times 2 is 4. Again, I have common denominators, but the square roots are not identical. So in the end, it's going to be the square root of 6 plus the square root of 2 over 4. And that's going to be our final answer. So if you have questions, let me know, and I'll see you soon.